Hi everyone. Today we are going to see the wide use of integration in finding the areas of the curves. Children, in your previous and lower classes, you must have read to calculate the area of simple figures like triangle, square, rectangle, and so on. But if you are given with simple curves, like if you are given with the figure of cos x or sin x, or if you are given with an ellipse or in parabola, then how we can find out the area under these curves. So these are the 5 simple steps that you have to follow to find the areas of the curves whose direct formula you do not know. So let's see these simple 5 steps. Children, first of all, you need to draw the diagram according to the given equations. You need to find out that what are the equations given to you, whether the equation is of circle, parabola, ellipse, or cos x, sin x, like that. And in board you will get 1 mark for drawing the diagram. Secondly, you need to see always for a perpendicular line in the given curve. Thirdly, you have to look for the area that area contains which part of the curve. If you are taking a simple curve, then of course you will be getting just one equation and you have to use that. But if you are getting combination of two curves and you need to find out the area enclosed by these two or more than two curves, then you need to find out the part of curve that region contains. Fourthly, you have to integrate with respect to dx if you are taking the limits along x-axis, and if you are taking the limits along y-axis, then you have to integrate with y. Yes, you will be making the function also. Since you are integrating with respect to x, that means your function should be in x only. If you are integrating with respect to y, then the function you will be forming will be in terms of y. And then you have to use the methods and formulae which you have read in chapter 7. Now let's see how we can apply these simple 5 steps in the given simple curves first, and then we will take the combination of 2 or more than 2 curves. Children, let's see how we can find out the area of these simple curves by using integration. This is your shaded area, that means these region you need to find out, the area of these region you need to find out. Now let's see, first step, draw the diagram according to the given equation. So this was the given equation and I have drawn the diagram according to the equation. The center lies at origin 0, 0, the radius is 1, that's why I have drawn it like this. Now how I can find out the area of the shaded region? Now children, first of all, I have drawn the diagram. Secondly, see for a perpendicular line. So this is my perpendicular line I am getting in the figure. Now look for the part of curve used in the area and use that. Now we have just one curve, that's why I will be using this equation only. Integrate with respect to dx. Now find out the function for it. So you will be doing integration. That means you are moving from here to here. So limits you will be putting from 0 to 1, integration from 0 to 1, and since you are moving along x-axis, so you will be integrating it with respect to x, and the function you will be forming by the given equation of circle. So here, since you are integrating with respect to x, so you will be framing it in terms of x only. So y square equal to 1 minus x square and y equal to under root 1 minus x square. So this is the function whose integration you have to do. Now use the methods and formula of chapter 7 to get the required area. So here you will be using the formula of under root a square minus x square, and then you will be putting the limits and solving it. Let's see for the next figure. This figure is given to you for cos x. Now I need to find out the area of shaded region. Alright. So draw the diagram. So according to the function I have drawn the diagram. See for a perpendicular line in the shaded region. I don't have any perpendicular line in this. So my aim will be to get the perpendicular line. For that I will be drawing a perpendicular line on my x-axis. Now, how will you be framing the limits now? Look for the part of the curve. So here we are having just cos x as my curve. So I will be taking the equation as cos x. Now that means you have to move from here to here. Integration, you will be writing it here. Integration of pi by 2 to pi, and you will be taking it as cos x dx plus from here to here, and then you will be moving from here to here. That means integration from pi to 3 pi by 2, and then again cos x dx. So this will be my integrand to find out the area of this shaded region. Now let's see for the third figure, children. Here you are getting a triangle and it is perpendicular line only. So either if you know half base into height formula, you can directly apply over there. But if you want to use your integration method, then how you are going to do? You are moving from 0 to 4. So integration of 0 to 4, and your equation is given to you x plus y equal to 4. So obviously you are moving along x-axis. So you will be framing in terms of x. So y equal to 4 minus x. So you will be writing it as 4 minus x. So here you will be finding out the integration and getting the area under this curve. Now you see this is a parabola whose standard equation is y square equal to 4ax. Now that means you are moving, if you want to find out area of the shaded region, that means you will be moving from 0 to a, and since you are moving along x-axis, so you will be integrating with respect to dx, and then you will be framing it in terms of x. So this is y square equal to 4ax. I can write it as y equal to under root 4ax, or simply I can write it as twice under root ax. So I will be writing it as twice under root ax. A is again a constant, you can take out, so you can write under root a outside only. 2 under root a integration from 0 to a root x dx. Then you can apply the formula for finding the area under this curve. Now let's see how we can find out the area if we are given with combination of 2 or more figures. Let's understand the area to be calculated under this curve, and if we want to calculate the area of this curve. So this is the equation given to us. We know this is equation of circle which is passing through origin. That means the center lies at origin, and your radius is here r square equal to, I can write it as like this, so r equal to 4 root 2. So this is the distance or the radius, which is 4 root 2 comma 0. Alright. Now children, first of all, just by using this equation, I have drawn the circle. I was given with one more equation of line which is passing through origin. So I have made the line also y equal to x. So first of all, I have drawn the diagram. Now see for a perpendicular line. Children, I want to calculate this area, but I don't have perpendicular line in it. So I will be getting a perpendicular line by drawing a perpendicular line from the intersection point of both the curves. So I need to calculate, when I want to calculate the area of this shaded region, then I need to move from here to here and then from here to here. That means I need to calculate the coordinates of this point. How will I be calculating the coordinate of this point? By calculating the intersection point. So you can find out the intersection point by using these two equations, given equations. So here, when you will be substituting it, you will be getting the common point as 4 comma 4. So if you know this point, then you can also put the point over here that this is 4 comma 0. Alright, this is 0 comma 0. Now how you can frame the integration like this. That means you are moving from 0 to 4, and to find out this area you are using the equation of line. So I'll be using y equal to x, that means x dx plus integration. Now you are moving from 4 to 4 root 2, so 4 to 4 root 2, and to find out the area of this region you are using part of the curve. So you will be calculating your function from here. So y square equal to 32 minus x square, and y equal to 32 minus x square under root. So I will be getting it as 32 minus x square dx. Since I have taken the limits along x-axis, that's why I have framed the function in terms of x and I am integrating it with respect to x. Now here you have to apply your chapter 7 formula. Now let's see in the next figure. Here I am given with equation of circle whose origin lies at 4, 0. That means let's suppose this is my origin, this is my center, 4, 0. Alright. Equal to 16. So radius here it is given to you as 4. So this is the radius which is 4, and I can find out this coordinate also. This is 4, this is 4, so this is 8, 0. Alright. Now I want to find out the area of shaded region. But perpendicular line is missing in this. So I will be dropping a perpendicular. So this is your perpendicular line. You are dropping from the intersection point of both the curves. Now you have to move from here to here and then from here to here. But when you are calculating the area of this region, then you are using part of your parabola. That's why you will be using the equation of parabola to frame the function. That means I am moving from 0 to 4 dx, since I am moving along x-axis, and now I am using the part of parabola. So I will be using my equation of parabola. So y equal to 2 under root x, I can write it like this, plus again you have to move from here to here, that means 4 to 8. But to find out the area of this region, you are using part of the circle. That's why you will be using equation of circle. You can simplify it and find out. So simplifying and finding out the function in terms of x will give you under root 4 square minus x minus 4 whole square dx. Now you can use your chapter 7 methods and formulae and you can get area under the curve. So children, follow these 5 simple steps to calculate area under any sort of curve. Isn't that easy?